All right, let's get started. Welcome everyone to Impart's first ever celebration of Women in STEM event. My name is Candice and I'm the Director of Strategy and Partnerships at Impart, and I have the pleasure of hosting our event today. I wanted to begin by thanking all of you for joining us and sharing a land acknowledgement. Although we're meeting virtually, I want to acknowledge that I'm attending this meeting from the traditional unceded territory of the Wolastoqey, Mi'kmaq, and Passamaquoddy peoples. This territory is covered by the Treaties of Peace and Friendship, which these nations first signed with the British Crown in 1726. The treaties did not deal with the surrender of lands and resources, but in fact recognized Mi'kmaq and Wolastoqey title and established the rules for what was to be an ongoing relationship between nations. I'm grateful to have the opportunity to work on this land today. I'd also like to acknowledge that virtual participants are gathered on many sacred lands and traditional territories. So I encourage you to reflect on the land on which you're located and to consider your relationship to the land and the people who are the traditional keepers of that land in a moment of silence. Before we begin the presentations, I wanted to share a few housekeeping items with everyone. First, and most importantly, both sessions of our event today will take place on the same Zoom link, so please remain on the line when the research rounds are completed so you can watch the Women in STEM panel. Second, I'd like to encourage everyone to use the chat box feature throughout the event today to share your questions or connect with other Impart members. I'll do my best to moderate the chat and ensure that your questions for each of our speakers is asked at the end of the presentations. And lastly, we want our participants and those listening in to have an exceptional experience and believe in providing a safe and welcoming environment for all. Please, no disruptive behavior or harassment of any form in the chats or otherwise. Otherwise, you may have to be removed from the event. So now that we've covered the housekeeping items, let's kick off our event with a series of presentations from young women researchers within the Impart team. For the research rounds component today, each speaker is going to have about 10 minutes to present one of their research projects to the audience. Following that presentation, audience members will have 5 minutes to ask questions using the chat or the Q&A function before we transition to the next speaker. So to kick us off, I'd like to hand the floor over to Natalia Fana, who will be presenting on the Impart Medical Technology Clinical Research Program. Natalia, over to you.
Thank you, Candice. Okay, just make sure everything works. Can you see okay my screen?
Yes.
Yes, perfect. All right. So thank you to everyone who is attending today's special event and who is interested in knowing more about what projects are the Impart trainees working on. I am proud to be representing Impart and to give you an overview about what Impart Medical Technology Clinical Research Program is about. So just a quick program overview. As you can see from this infographic, our MedTech is a multidisciplinary team of clinicians, research scientists, and biomedical engineers focused on clinical development and process automation of evidence-based, person-centered medical technology innovation, such as non-invasive digital devices for vital sign monitoring, digital therapeutics, medical decision support systems, or patient health gamification, and other virtual care assistive technologies that benefit vulnerable patient groups. Our team's expertise aligns well with the medical history taking and monitoring that informs the decisions and actions of care providers. Examples include vital signs such as the heart rate and blood pressure that can be monitored by patient, or with the support of an informal care provider from their home to facilitate preventive medicine, lifestyle modification, medication, titration, and adherence, as well as for early detection or worsening of a disease. Advances in healthcare technologies are changing the standard of care to reduce healthcare costs and to be more convenient for physicians and patients to effectively improve health outcomes. So we as a team, we clinically calibrate, validate, and assimilate healthcare technology innovations into a real world setting. Excuse me. Our work would not be possible without our collaborative industry partners. So let's discover who they are. Our first partner in the picture is a comprehensive care platform for aging adults. Routinify is a company based here in New Brunswick and also in Colorado, United States. Routinify offers a telecare service called Well Assist that supports and monitors the health, safety, and well-being of aging adults so they can live independently at home. Real-time data is collected from wearables, medical devices, and in-home sensors that can be monitored and reviewed by a nurse or family doctor. The middle picture is representing a wrist device and is our second industry partner with whom we work. The company is called CloudDX. We currently work with them on 2 clinical trials to calibrate the non-invasive wrist blood pressure device that has the unique capability of acquiring the breathing rate simultaneously. This company is located in Canada, in Kitchen, Ontario. Our third industry partner is Osculo Sciences, and they have the Edgett system, which is a rapid non-invasive device for the early detection of coronary artery disease. The Edgett device records the blood flow sounds of turbulent flow in blocked or partially blocked arteries of the heart. So with all this information, I come to the audience with a question. So does anyone know how long it takes a device to get on the market and what are the steps involved in? So just take a wild guess in your mind, and I will give you a quick overview of the steps. So here's an infographic that shows you the steps from the idea to the time it gets on the market. As you can see, an approximative time is 3 to 7 years, and it goes through multiple steps by the time it makes it on the market. But the timeline is also decided on factors where if it's a continuous process or if the company cannot support its research and gets bought by another company. And those are, I would say, steps into the process where there can be some delay. So I would like to next share the timeline for our CloudDX industry partner and what we're currently working on. As you can see from this timeline, the BioSign, it started under the BioSign in 2013. In 2014, we started working with them on the CloudDX device. And we started with the clinical trial for the blood pressure algorithm development. In 2017, we did the respiratory rate algorithm development. And for 2021 and 2022, we're working on the calibration of the blood pressure and respiratory algorithm. And this year, we are hoping to validate the device. So what does it entitle when I say calibration or validation? In order to do, now we're at the calibration phase. So as you can see in the image, I have provided what devices were used for both study, for the blood pressure calibration and the respiratory calibration. There are standardized protocols that we follow, and in this specific case, in our case, we follow the Association for the Advancement of Medical Instrumentation, European Society of Hypertension, an international organization for standardization standard protocol that was proposed by Dr. George Sturgeon and his colleagues. This standard gives us, I would say, a template on how to calibrate and validate the blood pressure device. So as of now, for the blood pressure device, we have a target of 200 participants. So far, we have recruited 56. And for that blood pressure study, we use this gold standard, which are the stethoscope and the sphyganometer. We are two research assistants, research associates, take manual auscultatory blood pressure and then also take a blood pressure with the device. Calibration and validation of phase for non-invasive blood pressure monitoring entitles population studies in which readings made by the monitor under test, which in our case is the wrist blood pressure device, and those made by a reference method are obtained simultaneously or sequentially, how we're doing. The measurement accuracy of the monitor is characterized statistically by the extent of agreement between the monitors and the reference reading. For the respiratory calibration study, we also using a gold standard, as you can see, we have a target of 80 participants for this phase for the study, and so far we have recruited 22 patients, and we use the gold standards, and this case is the ALICE-6 device, to compare the breathing or respiratory rate received or collected by the device with the measurements that the wrist cuff is obtaining. So as of now, we are in the calibration phase, and we're hoping to move to the next phase, which will be the validation phase, but this cannot be completed until the algorithm is not set into the device. During the validation phase, which is next, and hopefully we can complete the calibration by early fall and start the validation phase, where we'll use the same equipment and additionally predicate devices. So this completes my presentation with a quick overview on our medical technology program. It is different than the rest of the research we hear because it's targeted on medical devices, not specifically on laboratory research. So please feel free to ask me any questions or reach out by email if you would like regarding this topic. Thank you so much.
Thank you, Natalia. That was a really excellent overview of the medical technology program that you're working on at Impart and DMNB. And I guess I'll open the floor for questions from our audience. But first, I'd just like to ask you, why do you think it's important that researchers validate technology for companies that are looking to hit the market when it comes to these types of health technologies?
I think the most important is because we're providing a non-biased opinion, and we also don't have any financial interest invested in the company. So we can tell them if the device works or it doesn't work. And we are also can provide peer-reviewed publications. I think that is the most smart way for the companies to go through an academic partner.
From the audience, we have a question from Ashley. Natalia, can you explain a bit more the importance of measuring blood pressure? What happens to health when blood pressure is too high or too low?
What happened to, I don't understand the question. What do you mean, Ashley, by what happens to health? It's deteriorating either or, and it leads to more health complications. So it is important to be able to monitor the blood pressure, but not only monitoring it, but also obtaining accurate readings, because many times we do have a blood pressure monitor that can can give us measurements that are not necessarily correct. As my colleague Sarah has been promoting over the years, that 90% of the devices on the market are not clinically validated. So that's concerning, because you may be, unless you don't go to the hypertension clinic or to the doctor's office where you monitor you are monitored with a device that is trustworthy and it's considered a gold standard, you may be treated for hypertension or hypotension incorrectly. So it's important to be aware that when buying a blood pressure device, you should be checking to see if it is approved by Hypertension Canada. And not a lot of people know, but that is one of our goals when we are in the clinic with the participants, to ask them if they have a blood pressure device. And if they do, where did they get it from? Do they know if it's clinically validated? Does it have the hypertension clinic? So our work extends beyond collecting data. I feel like we are also promoting knowledge translation and trying to help patients as much as we can. We are not in position to give advice, but we can definitely share our knowledge, what we know from evidence-based research.
Ashley says spot on, and I would agree. I think that extra added piece about helping patients with build health literacy when you're going through those tests with them is incredibly helpful, and an opportunity to translate the information that you are learning to the population that needs to be using it. So thank you, Natalia, for that excellent presentation. We're going to move on to our second speaker now, and I'd like to introduce Maggie Pickard, who will be telling us about her research on nutrient sensing as a means of better understanding complex diseases. Maggie, off to you.
All right. Okay, get that up here. All right, sorry about that. And thank you, Candace, for that introduction. Like Candace said, my name's Maggie, and I am a master's student working with the Pollen Canal group at Dalhousie Medicine, New Brunswick. And I'm going to share with you all today a little bit about the research that I do. So without further ado, we can start here with my presentation. You are what your cells eat, exploring nutrient sensing to better understand complex disease. So just to get started here, to give you guys a little bit of background about myself and my research journey. So I graduated with an honors degree in 2021 from Mount Allison University. And my research journey started there, where I completed a honors project in Dr. Jillian Work's laboratory, where we did research relating to G protein coupled receptors. And now, as I mentioned, I'm in the first year of my master's program at Dalhousie Medicine, New Brunswick, in the biochemistry and molecular biology department, working in the nutrient signaling metabolism under the supervision of Dr. Pollen Canal. So today I'm going to tell you guys all a little bit about my research. So I'm going to start with some general background information about obesity, and then moving on to explaining a little bit about obesity and how that connects with metabolism, and then getting into more specifics about my project and what I do when I'm working in the lab. So let me start by introducing you all to the wider reach of this research project, which is obesity, and in connection with that, type 2 diabetes and insulin resistance. So obesity is a growing cause of concern, and it's a rapidly growing endemic. So obesity is defined as having a body mass index, or BMI level, which is measured by your body mass over the square of your height. So when that BMI level gets to be over 25, that is considered in the category of obese. So what we see in this first map here is global obesity rates by sex. So what we see is that worldwide, where the colors are darker, that means that the mean body mass index in that country is over 25. So what we see is that in a lot of countries in the world, including in Canada, that mean BMI are considered obese. And then even closer to home, what we see in the second map here is some growing cause of concern for the burden of obesity throughout the different Canadian provinces. And actually what we see here is a map that models the predicted burden of obesity in the different Canadian provinces. And it actually showed that the Atlantic provinces were predicted to have a higher burden of obesity than a lot of the rest of the parts of the country. So what this really shows here is how close this can hit to home and the importance of studying this disease clinically and in laboratory models. So now that we have kind of gone over and understood the burden of obesity and what that looks like around the world, I want to explain a bit more about what the effects of obesity are in the body. So like I said already, obesity is highly correlated with the onset of type 2 diabetes, which makes the body unable to respond to the hormone insulin. And this severely impacts the way that our bodies respond to food and nutrition, and then overall severely impacts overall health. So the onset of obesity is preceded by a multitude of factors, but that can mainly be summarized by a combination of calorie overload and lack of exercise. And then this can be combined with a lot of other risk factors, so age, gender, genetics, socioeconomic factors. There's a lot that goes into the development of obesity that is kind of more than just eating and not exercising, but that's kind of the best way to summarize it. And then what comes after the onset of obesity, and this is what we're more focused on in investigating in the lab, are the metabolic effects of obesity in the body. So obesity has been shown to lead to fat accumulation and overload. It also is connected to, in the muscle, disrupted metabolism and disrupted insulin action. And then obesity has also been highly correlated with the onset of heart disease and can be a contributing factor to heart failure. So now that we've gotten some of this background information out of the way, just to shift towards more about my own project, I'm going to start by talking a little bit about amino acids. So amino acids are organic compounds that play some really important roles in the body. So this figure here tries to summarize them all. It's not really showing them all. Amino acids are just incredibly important players in the body. So they're important for regulating appetite, metabolism, and they act as energy substrates. And then the kind of most important role is that they act as building blocks for the synthesis of proteins in our bodies. So the different amino acids are grouped into two different categories of essential and non-essential. So essential amino acids are those that as mammals we can't produce ourselves. So we actually have to get them from the diet. And then a specific subgroup of amino acids, because they're organized into some different categories that my project is interested in, are the branched chain amino acids. So these are isoleucine, leucine, and valine. They're called branched chain amino acids and it has to do with their chemical structure. And there are a few very important amino acids that have important roles in how the body responds to hormones like insulin and metabolism. And then, of course, they're also important for building proteins. And then, fun fact, they're actually very popular as a dietary supplement for people who are interested in kind of weightlifting or gym goers, because they are involved in helping you build muscle. So some people in the audience may have heard of branched chain amino acids being used as a supplement in that way. So getting more into the research project side of things, previous work in our lab was centered around branched chain amino acids and kind of looking at the connection between these organic compounds and obesity. And the organic compounds, the branched chain amino acids, and then branched chain keto acids, which are just one of their breakdown products. And what we found in this previous study in our lab is that branched chain amino acid and branched chain keto acid levels were elevated under conditions of obesity and high fat, and that these higher levels of branched chain keto acids were contributing to disrupted heart and muscle metabolism, and also disrupting the action of insulin. So what this really did here was set a very important stage for defining the role of these metabolites in metabolism, and then connecting them with a role for the onset of disease. So this was a very interesting finding, of course, but moving forward from here, where we saw what was happening, and then we kind of began to look at some reasons why this may be happening and investigating different mechanisms in the cell. The question we really wanted to ask was how? How is this happening? How do cells sense these changes in nutrient levels and these different levels of metabolites, and how is the body responding to that? So we wondered if something within the cell or tissue was detecting changes in branched chain amino acid content, thereby helping to modify how the body was responding. And so as this was kind of coming together, Dr. Tonkanel was pondering this and looking at moving forward with this project. Another research group published their findings identifying a protein called SAR1B as a leucine sensor protein, meaning that it was able to detect levels of leucine, one of the branched chain amino acids within the cell. So if we think of SAR1B here like a little detective protein, where it was able to detect low levels of leucine and able to shut down protein synthesis and the roles of leucine, but then when leucine levels were higher, it was able to sense that and resume these protein building activities. We were envisioning if maybe this leucine sensor protein, as it was detecting these changes, could have been playing a role in leading to the whole body effects of these branched chain amino acid levels. So was SAR1B detecting changes in nutrient content, and then was it playing a role in the whole body response in the onset of disease? So now if we bring this back to the findings, what we found previously, so I'll have you look again at this little diagram from earlier and think about the questions that I was starting to ask and the questions that are forming my research project, is whether SAR1B's ability to act as that detective protein was having a relationship in either direction with obesity. So what is the connection between obesity and levels of SAR1B, or our levels of SAR1B impacting disease onset of obesity? And then we also want to look at how SAR1B and higher branched amino acid and branched chain keto acid levels are impacting one another. And then overall, what is the impact and what is the relationship between the SAR1B protein and disrupted heart and muscle metabolism, and specifically insulin action in those two different tissues, to help us better understand SAR1B's overall role in metabolism. So now that we've covered kind of the basics of why I'm doing that, I'm going to spend the last little bit of my presentation talking about what this kind of looks like for me in the lab and giving you all an idea of how this research plays out for me. So what I'm currently working on is one aspect of my research project is genetically altering the levels of SAR1B protein in specific cell lines. So if you think about these little cells in a dish, I work with rat cardiomyocytes and then mouse skeletal muscle cell lines, where I'm working to alter. So by alter, I mean either to increase levels of or decrease levels of the SAR1B protein within these cells, and then use those cells with altered levels of SAR1B to examine the metabolic impact. So once the level of SAR1B is altered within the cell, there are tons of different tests or different functional readouts, as we call them, to look at to see, okay, so if SAR1B is changing, then what's happening in the rest of the cell? What's happening to the metabolism in the cell? And this is all kind of going forward to help us get a better understanding of what role SAR1B is playing. And then because I couldn't get away from this presentation without showing a tiny bit of data and some of the stuff that I'm collecting so far, let's look at what we actually see, what I'm talking about, and how I measure whether SAR1B is being decreased or increased in the cell. So this is what it looks like after SAR1B is being genetically modified to have decreased levels in the cell. From the cell, we can collect protein and process the samples through a protein gel. And then we move on to Western blotting, which allows us to detect levels of specific proteins in the cell and then image them, where essentially what you're seeing is that the thicker bands are indicative of higher levels of protein in samples, and then fainter bands mean that the level of the specific protein that I'm looking at, SAR1B in this case, is lower. So what we can see here is that in the first 3 bands were my control cells, and then in the samples where they were genetically modified to have decreased levels of SAR1B protein, we have fainter bands and therefore lower levels of SAR1B protein expression. Therefore, this is kind of what I've been working at so far, knowing that we're able to decrease the SAR1B levels in these muscle cells, which is a step towards using this kind of model with genetically modified SAR1B content to continue on with different readouts and see how these altered levels may have metabolic impacts in the cell. And with that, that kind of brings me to a little bit of a conclusion about why I think anyway, this research is important. So first of all, this could be really important for advancing knowledge on how sensor proteins are able to impact whole body metabolism and disease onset. It'll help us to understand a little bit more about how our cells are responding to changes in nutrient levels and really sensing the changes that are going on and how it's all connected to lead to responses. And finally, it'll specifically with this protein SAR1B, we'll explore SAR1B's potential to govern the action of insulin and also overall muscle and heart metabolism. And with that being said, I just want to say thank you all so much for listening, and thank you to Impart for having me. And then also a big thank you to all the members of the Nutrient Signaling Metabolism Laboratory, without whom none of this would be possible. And with that, I'd be happy to take any questions at this time.
Thanks so much, Maggie. That was an excellent overview of your research project. I will open the floor to questions in the chat or the Q&A, and I'll start off, Maggie, just by asking you, I think you highlighted at the start how you got there, and you highlighted at the end why it's important, but I'm wondering if you can tell us a little bit more about why it's important for you, and what really makes you passionate about the research that you're doing.
Well, that's a really good question. I think the reason that I'm so interested in it is that I've always been really interested in kind of how the body works. And obviously there's so many people that are impacted by diseases like obesity and type 2 diabetes, but kind of one of the worst parts about those diseases is that they're connected to a lot of other diseases and like comorbidities between different diseases. And I mean, you see it now, right? With like COVID-19, the pandemic, like obesity and type 2 diabetes are huge risk factors and comorbidities. So I think better understanding how everything connects at a cellular level is really important for understanding diseases in a greater context and how they connect with one another.
Thanks, Maggie. Brittany, I'll let you ask your question and then we'll go to the next presentation.
Thanks, Maggie. That was a really interesting presentation. Great job. I'm curious, insulin action is shown to affect mTOR downstream. How do you think SAR1B might be interacting with insulin upstream, or how do you think it's going to affect insulin action? If you have any hypotheses this early in the project.
I'm really glad you brought up mTOR because that's the kind of part that I took out. So SAR1B is actually acting as a leucine sensor through the mTOR pathway. So SAR1B is an inhibitor of Gander in the absence of mTOR. So the kind of hypothesis we're looking at, so we saw that the higher levels of branched chain keto acids were inhibiting insulin action in the muscle. So what we're hoping is that if SAR1B is overloaded, if you overload SAR1B, could the SAR1B have the potential to kind of save the impact of the higher branched-chain keto acids and the higher activation of mTOR on that downstream insulin signaling? So could SAR1B save mTOR's impact on insulin resistance?
Very cool. Thank you.
Thank
Thanks
you.
so much, Maggie, for that presentation. I'm going to welcome Tori now, who's going to be speaking to us on the why, what, and wonders of cardiac research. So take it away, Tori.
Awesome. Thanks so much, Gander. Okay, awesome. So hi, everyone. Thanks so much for coming today. So excited to be here and share this talk with you. So as Candace mentioned, I'm going to be talking about the why, what, and wonders of cardiac research. So starting from really basic terms, giving some background on the heart and other things that come along with it, and then focusing a little bit more on what I do for my research in particular. So start, background on myself, background on the heart, how it works, some cool things about it, followed by why get into cardiac research, what is cardiac research, and some of the wonders that I think that I've discovered or that are still to be discovered in research going forward with cardiac research. So to start off, just a little bit about myself. From high school and really a young age, I've always been interested in science. It's something that I always found really intriguing. So that brought me to UNB in Fredericton for my undergrad, where I did my honors project and majored in medicinal chemistry, which is the focus of the design and synthesis. From there, as much as I loved the development, I wanted to follow through and see what these medications did long term, which has brought me to my master's project here at Dalhousie in St. John, focusing in pharmacology, which is the study of drugs and how they interact within our body. I found
Tori, you're cutting out a little bit. Can you test your headphones again? You're just kind of cutting in and out.
Or is that better?
Yeah, I can hear you better now.
Okay, thank you. Okay. All right. So as I'm sure you guys have all heard of a heart attack, hopefully not in related to anyone close to you, but just to give a little bit of background about what a heart attack is and what is really happening. So it is a leading cause of morbidity and mortality worldwide, which is impacting people's lifespans, obviously, and quality of life. And it's described as a reduced or stopped blood flow, which can be caused here as an example from blockage, such as plaque in our veins and arteries that reduces our blood flow to our heart, but it can also be caused by things such as spasms of the arteries and veins. So there are multiple different causes that can cause this reduced or stopped blood flow. And this reduced blood flow or stop of blood flow is really detrimental because with this blockage, the organs and your heart are not receiving your oxygen that you need within your body. And this leads to symptoms like tightness of chest, shortness of breath, nausea, sweating, and vomiting. Now here, it's really important to note that these are the common symptoms of a heart attack. However, they differ significantly between men and women. And it's actually been seen that a lot of women experience lesser symptoms than men, which is quite interesting. So with that being said, what happens to your heart after you have this injury? So here in a normal heart, you have your right atrium, your left ventricle, and your right ventricle. So here you can see this nice healthy heart muscle. And then in our injured heart, so after something like a heart attack, you see here that this ventricle has gotten significantly larger and that the cell or the heart muscle here has gotten thinner. And this is because of that cell loss of the lack of oxygen coming from the blood supply. And that in particular is a loss of cardiomyocytes, which are cells particularly found in our heart. So just to give a demonstration of what this looks like, we'll see if we can get this to play. Sorry. So this is a healthy heart, nice rhythm, nice thick sides. You can see here, and it seems very synchronous. However, in an infarcted or an injured heart, you can see here that it's quite lopsided, and you're not seeing the full contraction of the heart that you would see in a healthy heart beside it here. So what does this really mean long-term for patients? Because of this dilatation of the ventricle and the stretching and the workload of the heart, this ventricle becomes larger and larger and larger, and the outside becomes thinner. And that causes heart failure in the long term. So the progression of the disease typically happens from a heart attack into heart failure, unfortunately. And this heart failure can lead to more detrimental effects in the body, like injuring other organs or causing failure or dysfunction in other organs, such as the brain, the liver, the lungs, and also your blood. So with that being said, what is cardiac research and what areas are we really focusing on? So we started with our why. We can see that there are detrimental effects caused by initial injury to the heart that can lead to long-term effects like heart failure that has impacted. I was just reading the other day that in Canada alone, there are 750,000 people who are impacted with heart failure currently. So what are some areas of cardiac research that could be looked at? So there are vast majority of different areas that are included in cardiac research. However, in this presentation today, I just demonstrated a few of them. So there are certain areas that looking at decreasing the likelihood of heart attacks. So things like exercise have been looking at, but also what you eat. So looking at that is another area of cardiac research. Again, looking at the causes of this initial injury of a heart attack and also progressing into that heart failure. So what are the causes of the two? And as I just mentioned, we see that a lot of patients progress from a heart attack into heart failure. So being able to stop this progression would be really important in bettering the outcome for patients long term. And additionally to that, looking at better treatments for heart failure patients so that they can live the best quality of life that is possible. So in my research in particular, I look at stopping the progression from this initial injury of a heart attack into heart failure. So why does the heart progress initially from this heart attack into heart failure? So in the skin, like when you would get a cut, it would heal over right away and you would have new cell growth that would cover up the injury. And if you had a deeper cut, you would see that scar tissue would form and you would form a scar on your skin. So unlike skin cells or most other forms of cells, heart cells or cardiomyocytes in particular are one of the only forms of cells in our bodies that actually currently don't regenerate. So our hearts are really great at forming a scar after the initial heart attack, which is why we get that dysfunction and long-term consequences to heart failure. However, as of current, our cardiomyocytes do not actually regenerate, so we can't replenish those cells that are lost within our heart. So for me, this brought me to my project. And initially I wondered, well, obviously there has to be something responsible that creates our heart when we were originally born, and what is responsible for forming that heart, forming our hearts when we develop as babies. So that is where my path led me, and it actually led me to the hippo-yap pathway, which is kind of fun and exciting. But this is the pathway that's responsible for developing our hearts as babies. So here on the bottom, you can see that this is the normal size of a heart with your right atrium, left atrium, right ventricle, left ventricle, and that it was actually seen that increasing the activity of this hippo-yap pathway almost doubled the size of the heart that you can see over here. We asked ourselves is that if this is possible in babies' hearts or in neonatal hearts, is there something that could be responsible for doing this in adult hearts? So that brought me to my research when I was wondering to answer this question. So it brought us to 3 major nutrient substrates to see if we could use one of these or a combination of these to be able to reactivate this hippo-yap pathway that's shut off in adult cardiomyocytes to be able to promote this regeneration of cardiomyocytes. So for my research, I used 3 major techniques seen here with immunofluorescence, which is looking at the whole cell, seeing here the nucleus and the membrane, and trying to look at is an entire whole. In addition to immunofluorescence, I also use qPCR work in my lab and in my research to look specifically at the gene level. So like the closest level that we can really look at in these cells, and also look at this in terms of the protein level. So we go from the gene level to protein level all the way to the whole cell level. Now, with that being said, using these techniques so far, we have determined amino acids may be responsible or may aid in regenerating these cardiomyocytes through the hippo-YAP pathway to be able to promote regeneration of those cardiomyocytes, which could in turn lead to better outcomes for these patients. Now, wouldn't it be so cool if you could just have some amino acid shot after you had a heart attack to be able to improve your outcome for these patients? It would be so neat if it could be something that simple. So that is where my research has mainly taken me. But I just wanted to highlight in this presentation, since it is for women in STEM, how important that it is that women be involved, and the fact that over the recent years in particular, we've determined that there is a huge sex difference between multiple different areas of research, including cardiac research, as seen from just the symptoms alone in a heart attack. So it's really important that women are getting involved, as a lot of the previous history has been focused mainly in male models and using a lot of male animal models in particular. So just to end on a fun little quote, it says, "If we don't look out for ourselves, who will?" And with that, I just want to thank everyone for listening. And if you have any questions, feel free.
Thank you so much, Tori. I have to say you've taught me a lot in this presentation about how the heart works and also how heart failure occurs. And I'm not sure it's made it any less scary, but it does make it a little bit more understandable. So I appreciate that a lot.
That was the hope.
And I think I think you've raised a really important point here about the sex differences in research and how important it is for women researchers to be looking out for those sex differences as it is for all researchers. So I want to thank you for making those points. I want to open the floor to questions before moving on to our final presentation. We are a little behind, so if there's one question, I will take it. Just taking a quick look through the Q&A in the chat here. Well, Tori, it looks like you explained things so perfectly that there are no questions to be asked. Well, thank you so much again. I'm gonna transition now to our last presentation from Anu, who's going to tell us about the role of lipid phosphates in obesity-induced insulin resistance.
Can you guys see my presentation?
Yes.
Okay. Good afternoon, everyone. My name is Anu. I'm a master's student at Dalhousie Medicine, New Brunswick. I work under Dr. Petra Kinesberger at Nutrient Signaling Metabolism Lab. So my research is to explore obesity-related signaling in heart disease. So as the title says, it is completely related to obesity-induced cardiomyopathy. Okay. So I'm from India. I completed my undergrad in India, and then I moved to Canada to finish my master's. So yeah, that's all about me, like from my personal background. So let's move on to the presentation. So as we know, obesity is a multifactorial disease with complex pathogenesis, which ultimately leads to adverse health outcomes, like hypertension, osteoarthritis, heart disease, type 2 diabetes, hyperlipidemia, obstructive sleep apnea, etc. This is not just these six issues. There are other diseases as well, but these are the most important one. So among these health issues, my research mainly focused on heart disease and type 2 diabetes or diabetes mellitus, or in a simple term, diabetes. We all know what is diabetes. So our body cannot produce enough insulin, or our body cannot use the insulin produced, which eventually leads to an increased level of glucose, right? So as I said, my research is mainly focused on obesity-induced cardiomyopathy. So let's see how obesity and diabetes, how it leads to cardiovascular disease. So over here, you can see that, let me open my laser pointer. Okay, so during early stage, this is a time course of diabetes progression. During the early stage, you can see here, because of the increased levels of reactive oxygen species, it can lead to inflammation, then insulin resistance, hyperinsulinemia, dyslipidemia, etc. Then during the mid stage, diastolic and systolic dysfunction, fibrosis, and so we know that, so that means obesity just starts with simple things, and it leads to diabetes, and finally to the death of that person. So which is alarming and concerning during these modern world. So everyone, somebody should look into all these kind of issues, right? Okay. So what happens during when one person is obese or overweight? So under these conditions, adipose tissue. So adipose tissue is the organ which stores fats as triglycerides or lipids, or in simple terms, fat. So when the person become obese, the adipose tissue may not be able to store the excess fat. So what happens during that excess fat levels is, when there is excess fat levels, it actually spill over to the lipid levels, circulating lipid levels increases, and it spills over to other non-adipose tissues such as skeletal muscle, heart, and liver. And it leads to lipotoxicity. So lipotoxicity is when lipids accumulate excess, particularly non-adipose tissue, as I said. So this lipotoxic condition can actually can trigger cell stress, cellular dysfunction, and apoptotic cell death also. So finally it leads to inflammation and insulin resistance also. So this lipids include DAGs, diacylglycerol, ceramides, fatty acyl carnitines, etc. There are a lot of this, but among those, the main lipids are DAGs, ceramides, etc. So that means the adipose tissue is now dysfunctional, right? So what happens when adipose tissue is not functioning properly? So, and under those conditions, adipokine produced by adipose tissue, so the secretion of adipokine is altered, and it can contribute to various obesity associated conditions, including cardiovascular diseases. Why? Because these adipokines regulate numerous physiological functions such as energy expenditure, fat metabolism, insulin sensitivity, secretion, etc. Such kind of, so they are like signaling molecules. So there are different types of adipokines. So I work with such an not adipokine, so such in that area. So autotaxin is one such adipokine. So when this previous studies, and also our lab also has also shown that increased ATX levels can actually induce inflammation or impaired insulin signaling. How? Let's see, how is that possible? So what happens, so what is the function of this ATX? So this ATX actually produces LPA from LPC. LPC is lysophosphatidylcholine, and LPC is converted to LPA with the help of autotaxin. LPA is lysophosphatidic acid. LPA is a potent bioactive signaling molecule. So when it binds with G protein coupled receptors, LPA1 to 6, it can actually it can actually induce various physiological signaling pathways. Also, this LPA production is, or the circulating LPA levels are maintained continuously, like produced and degraded. So it's a balanced level. So once LPA is produced, or if the LPA levels are going high, LPP3, which is an integral membrane protein, can actually degrade this LPA or lysophosphoric acid to monoacylglycerol. As I said previously, our lab has shown that partial ATX deficiency can actually improve insulin sensitivity under obese conditions. Under obese conditions. Also, different studies have also shown that increased ATX levels can lead to inflammation, then impaired insulin signaling, hepatic steatosis, impaired brown adipose tissue differentiation and function, cardiomyopathy, of course, adipose fibrosis, impaired glucose homeostasis, mitochondrial dysfunction, etc. So I said that LPA is converted to monoacylglycerol by LPP3 or lipid phosphatase 3. So this LPP or lipid phosphatase, there are 3 isoforms in mammalian cells, which is LPP1, LPP2, LPP3. But among those, LPP3 is robustly or explicitly expressed in heart compared to other organs. So that is the reason why I concentrated on LPP3, because my research is entirely based on obesity-induced cardiomyopathy, right? So, so that is all about ATX, LPA, and LPP3 axis, which is a signaling pathway I'm looking into during my this master's research. So my research, how I'm so these are my hypothesis, no, not hypothesis, this is what I'm going to look into. So when LPP3 is increased, does that going to influence or enhance or improve insulin signaling, mitochondrial functioning, glucose homeostasis, and cardiomyocyte contractile function? Or when, or if the LPP3 is silenced, or the levels are reduced, or just modulating, and seeing how this is gonna influence insulin signaling, mitochondrial function, and other metabolic pathways. So for that purpose, I have different experimental models in our lab. Among those, the most important one is I have a LPP3 overexpressed mice. I mean, cardiac specific LPP3 overexpressed mice. From that, which I will be using adult cardiomyocytes to see how this LPP3 is affecting insulin signaling and cardiac metabolism. Also, we have H92 cells, which is cardiomyoblast, which I'll be using to induce or modulate LPP3 in these cells, and then I'll try to see how this is changing in cell lines. Also, I'll be looking the LPP3 expression in atrial appendages from obese and non-obese people. Ultimately, I want to see if how LPP3 is changing under obese and normal conditions. So in previous slides, I've already mentioned that our lab has previously shown when ATX is silenced, or the level expression of ATX is reduced, or autotaxin is reduced, it can actually improve insulin signaling because of the lower levels of LPA. So if we are seeing the same thing with respect to LPP3, because LPP3 is degrading LPA, which is kind of a same effect, maybe we'll be able to see a signaling pathway which is clinically significant, which eventually leads to pharmacologically relevant pathway. So this is all about my research. Unfortunately, I didn't include any data because I recently traveled to India, so I couldn't take any of the data. So hopefully I'll be seeing some progress in my research. So yeah, so I thank all of my lab mates, all of my lab mates working under Dr. Kundil and Kinesberger. And thank you, Imbad, for this opportunity. Any questions?
Thank you so much, Anu, for that great presentation and for presenting, even though you recently went on your trip. We really appreciate you taking the time. I just had a question. I was kind of wondering, what drove your interest in this research and what made you start this research project?
First of all, I was always curious. I'm always curious to ask questions. Okay, why this is happening? What's the reason? So and obesity is something obesity research is something very impactful. So I thought, if I can do some research which is really impactful to others, maybe that is good. That's the reason. Yeah.
That's great. Thank you so much, Anu. And thank you, Maggie, Tori, and Natalia for your excellent presentations. We're going to be moving into the second component of our session today. So I'd like to welcome Sarah, Brittany, Shreya, and Sowmya onto your screens. We're going to be shifting gears now, and we're going to be talking a little bit more about pursuing careers in STEM, what makes our panelists passionate about the work that they're doing, and also what advice they have for other women and girls who are interested in STEM education. So welcome, Sarah, Brittany, Sowmya, and Shreya. We're going to start things off with you, Sarah. And before you get started, I'm just going to introduce you to our audience. So Dr. Sarah Gander is living in St. John, New Brunswick with her family and 2 boys, Eddie and David, and her husband, Steve. She's got a busy clinical practice in the newly opened Community Social Pediatrics Clinic and is a faculty at both Dalhousie University and Memorial University of Newfoundland. She's involved with numerous organizations in the community aiming to better the care of families and children living in difficult living situations, particularly poverty. She's also the founder of New Brunswick Social Pediatrics, a nonprofit aimed at advocating for child rights under the United Nations Convention on the Rights of the Child using a medical, legal, social approach and empowering the voices of children and youth in the Parent-Child Assistance Program. I'm going to hand the floor over to you, Sarah. Welcome.
Hi, can you hear me okay? Awesome. Hey, everybody. Thanks for having me. And thanks for the introduction. So I'm a general pediatrician here in St. John, New Brunswick, and New Brunswick is my home. I was born in Alberta, but I came here when I was really young. And so I feel like I was born and raised in New Brunswick, but I was actually born in Edmonton and then came here really young. So, but New Brunswick is definitely home for me. And I was born, I'm an only child, so and have a family of teachers and professors. And so education has always been an important part of my family life. But there's no physicians in the family. And so why would I want to go that route? We all find our mentors and our inspiration in different places in this world. And my mom's best friend was an emerge doc in Moncton, and she was just kind of badass, and she had her kids and she had her career, and she was just an awesome human and just wanted to do really good things in the world. And I was really inspired by her and inspired by my mom, who taught biology and chemistry in high school and was a mathematician. And so I was definitely drawn towards the sciences. And so that's kind of the route I took. And you know how things go in this world, it's kind of like, if you're good at those things, people say, well, you should do science and maybe you should do medicine. And then life things happen, my family had some tragedy. We had one of my aunt's children, so one of my close cousins, passed away of a brain tumor at just the age of 3. And so like watching the community come around them and watching medicine and watching what it means to take really good care of people be played out in my family was a big inspiration. And so as these things go in our brains, we say like, okay, I'm going to be a pediatric neuro-oncologist. And then you realize how many years of university that is. And you think, well, maybe I'll stop at being a pediatrician. But and so our lives just sort of lead us in different directions. I went to UMBSJ here in St. John, which is, you know, you look back at the decisions you make in this life, and that was probably one of the best decisions I made. Not only did I come out of undergrad without owing a whole lot of money, I lived at home while my mom cooked for me and did my laundry, and those formative years where we didn't get into too much trouble, just enough trouble to make it fun, but didn't have the big price tag, knowing that I was going to go further after my undergraduate degree. And I feel like I was very well prepared to go into medicine for my degree at UMBSJ. So I'm very thankful for that. I went to Memorial University, and going to Newfoundland was an absolute joy as well, and pleasure. And I was so blessed to be able to get into medicine right away. And then went to Queen's University in Kingston to do pediatrics. And I knew I wanted to do peds, and I knew I wanted to come home. And so having that foundation and base here in New Brunswick was fantastic, but then really feeling like going to other places and getting different experiences and taking advantage of really cool experiences, like even being at UMBSJ and going down to Cuba for a summer to study tropical fish, which has nothing to do with medicine in theory, but has a lot to do with just informing our brain and keeping us curious and having a bit of fun along the way. I was trying to think of what I wanted to say today, and then the universe provides. So yesterday I had a patient in the office who was doing a project on career day, and he kind of said, you know, in French, he's like, "Could you pose des questions?" And I was like, okay. And so he asked the best questions because they really made me realize what the message I think we should think about as women are, and what we bring to the table as scientists and as people interested in technology. And so he said to me, you know, what was the most important course that you took to prepare you for postgraduate time, you know, because he's going into high school. And at first my mind just said like, oh, science, biology, chemistry, like the usual answers. And then I thought to myself, I'm like, well, there's that, but, you know, English courses taught me how to communicate. And if there was something I could do differently, well, actually, I asked a friend the other day what they would have said, and they said drama. But, you know, just because we sometimes feel like we're on stage for patients all day long, but English to communicate and to have that ability to relate to others. But then with the current events in the world, you know, I've had to relearn history to really be able to do my job. So when we had Syrian refugees come in, and we had, and we continue to have lots of patients, I had to learn about the wars in Syria. Like, I did not know all the things. And so to really take good care of people, you have to meet them where they are, you have to know where they're coming from, and be able to help be with them on their path forward. And now I'm learning so much about Ukraine and Russia and the history of that, and my patients to be able to provide good care. I need to know more about the world than just how their cells work. So I think that's brought me to a career where I just really care about the whole patient, the whole family. As a pediatrician, as much as the kids are awesome and fun, and like 80% of my job is reassurance and saying like, yes, that's normal, it's fine. And of course, 20% is really challenging and heavy sometimes. It's really spending the time with families and the social determinants of health. So that's the poverty work that I do here in St. John. You know, where my clinic is, there's a 52% child poverty rate. There are kids who live in houses with dirt floors, and you know, order a pizza at the beginning of the week and it lasts all week, sort of thing, or skip meals, or the parents certainly skip meals so their children are able to eat. And so that's our reality. And unless you know the context in which people live, work, and play, you just can't do this job the same way. So the science and technology is like how the body works, but then there's also some innovative solutions I think that we can do as part of a STEM network to really say like, how can we do business differently? How can we do business better and make sure that we reach all the people in the community in an equitable way that really allows us to take our privilege and be able to share space with other people. So that's been the privilege of my life and my career, and hopefully can mentor people going forward, and certainly be part of an awesome group of women who can really take things to the next level. So hopefully I can answer any questions at the end of the panel. I'm looking forward to hear what my colleagues have to say in the group. So have a wonderful day.
Thank you so much, Sarah. I really appreciated your insightful comment there about the context within which people live, work, and play, and all of the different facets that every human is bringing to the table when they're coming to see their doctor about their health overall, and that it goes sort of beyond the biology and the chemistry and all the other science pieces that you've learned to kind of incorporate the liberal arts education to. I really appreciated that comment. I think really important for everyone to get the full picture, particularly in healthcare. I want to introduce our second speaker now, where I'm going to introduce Sowmya, who is an assistant professor in the Department of Computer Science at the University of Victoria. At UVic, she leads the Creative Experiences Lab and co-leads the VIXI Lab that focuses on topics in the area of human-computer interaction and information visualization. Currently, her research group is working on several projects that involve studying and designing tools that can help people create digital and physical artifacts using technology. The group also researches other topics related to designing new physical interactions for people, such as with autonomous vehicles and wearable cyborg limbs. Before joining UVic, Sowmya was an assistant professor at the Ontario College of Art and Design University in Toronto for 2 years. She completed her PhD at the University of Calgary. And before moving to Canada, she lived, studied, and worked in Bengaluru, India. So welcome, Sowmya.
Thank you. Thanks for the introduction, and thanks for inviting me to be part of this panel. I think that was a lot was already in the introduction, so I won't repeat myself. I think there were students who were in the presentation who were talking about a similar sort of pathway as me, saying they did their undergrad in India and are now here in Canada, doing their master's or PhD, and that's sort of my pathway to my STEM career here as well. So maybe I'll just go a little bit backwards as to why I guess in retrospect, how I ended up here. It wasn't really a plan or a sort of very decided pathway of saying, oh, that's definitely what I want to be. I think even till my third year of my PhD, I was pretty determined that I did not want to be a professor. So it's like, oh, that's not what I want to do. And things changed along the way. And I think that's sort of been my intro to computer science as well. I enjoyed computer science. I started learning it. I started learning programming in around 5th grade, and I learned some of the early programming languages like Logo. I don't know if folks are familiar, but it was this sort of visual language that you could see this mouse pointer move on a screen, and it could create shapes like a triangle, circle, etc. And the way you would program the computer was sort of very literal, like walk 5 steps forward, turn right, and do things like that. And that is what would create a visual on the screen. So that's how I learned it, and I really liked it. And going forward, I learned some more. And I remember spending time with my sister and my cousins, sort of learning to program. And if you guys remember the 90s website, it used to have this text that would sort of keep scrolling on a website with all these flashes, and we were like, oh, so excited to create those. They meant nothing, but we were like, oh, there's flashy text, that's so exciting. So that's sort of my introduction, and I was happy learning computer science, and I had good grades in it, but it wasn't something I knew that I wanted to keep doing for example, in my engineering. And I was one of those students who was like, oh, you know what, I'll write all the exams possible and see what I get, and then I'll see what I want to do. So I wrote an exam for architecture, I wrote an exam for engineering, and I even went to check law schools. And at some point I was like, oh, maybe I'll be a dentist. So science by eliminating the other options. So it wasn't like I want computer science. It's like, okay, I don't want the other thing, so I'll do this sort of a thing, is how I got into my program. And then along the way, I think it became a little bit more concrete. The decisions became more explicit, and they were decisions that I was making, not based on if I had a good grade in a subject or something, but more so because I wanted to do those kinds of things. So I had the chance to be an intern for a gaming company in India, and that was really exciting for the first time. You know, I had more sort of, I had the autonomy to create something of my own without, you know, my teacher saying, oh, that's exactly what you have to program. The company was like, yeah, sure, do what you want. And that was fun. And that's kind of how I ended up in my master's program. I was like, oh, I actually do like doing things on my own, and I want to be able to make my own decisions. And so that's kind of how I came to my master's program. And from there, I sort of got introduced to what is called human-computer interaction, which is a field within computer science, but it also borrows from many other fields like psychology, design, arts, and so on and so forth. And the interdisciplinarity of it is what really attracted me and kept me in it, and is kind of why I do my job right now. I like that I can take all of my computer science skills and apply it to different domains, whether that might be creating more fashionable e-textiles, or it might be creating better looking wearables, or allowing people to personalize their health devices so that, you know, it better responds to their day-to-day life needs. So that's the kind of work I do, and that's what really excites me. And I think the best part of my job is, at least now, now that once I became a prof, I think the best part of my job has been that I really get to work with amazing students and amazing colleagues who are very inspiring and work really hard. And, you know, that really helps me sort of stay on top of things too. And the fact that I have the choice to, you know, propose a project and shape it and sort of stick to my values and, you know, create things that I believe in truly and think that, at least I think they're meaningful. And, you know, I try to explore them and learn my lessons. And I like that sort of structure. And the good thing about being an academic is also that you get to collaborate with people in all sorts of parts of the world, and you get to learn from everyone, and that's exciting too. So yeah, that's why I think I'm in a STEM career. It gives me, it makes me feel empowered that I can do these things and I can make my decisions, and I like computer science because it gives me the tool to build stuff for people and try in my very small way to change what I can.
So Mia, I think what you said about, you know, not knowing which path you were going to go down, writing all the exams, I think that's so relatable for so many young women pursuing any education, right? I think there's a lot of pressure on students to have a defined outcome before they even started down the path of what their career is going to be. And I know that, you know, I went to law school and I was adamant to even the day after I graduated that I'd never be a lawyer. And then I went and became a lawyer. And then I was like, oh, but lawyers could be good people too. So I think there's just so much relatability to the story you just shared with us. And, you know, about taking your career and shaping it in a way that can ultimately allow you to contribute to the world and make it a better place. So I really appreciated that insight.
Thank you.
I'm going to welcome Brittany now. Brittany is an assistant professor with the Faculty of Kinesiology at the University of Calgary. She is an integrative exercise physiologist interested in the interplay between various organ systems to regulate cardiometabolic health, the mechanisms that regulate metabolic function, and how this differs in men and women. Welcome, Brittany.
Thank you. This has been great so far. I really appreciate you inviting me and seeing everybody talk earlier, as well as meeting some new faces here today. I'm very similar in terms of where I started. I didn't really know what I wanted to do early on. I enjoyed sciences like physics, chemistry, biology. I love sports. I still love sports. So that had a big part in molding kind of where I ended up through the kinesiology route of my training. But really, I enjoyed working with people. I enjoyed either playing team sports or working with people to achieve kind of, I guess, finding new information. That's kind of been like the guiding force between my career decisions, or understanding how does something work and why does that happen. And I think coupled with my interests in sports led me to focusing on the human body in particular. So that led me to do a human kinetics degree with a focus on kinesiology at St. Francis Xavier University in Nova Scotia. And that was really the first place I got a taste of research through my honors project. And that's kind of when I always knew doing that degree that I liked health science and I wanted to do something in that field, whether it be physiotherapy or medicine or anything that was helping people or working with people and also related to like physiology. That is what I was really passionate about. But that was the first time that I really thought, wow, this research stuff is really interesting. And it was the first time I was really experienced or open to the experience of bench work. So I was working with pipettes in a lab, testing urine samples for a specific protein, which the specifics of aren't really that important, but just going through the whole process of developing a research question, looking up the background information, and then doing experiments to solve a problem. That was really interesting to me. And it just so happened that I really took to the nitty-gritty details of cell signaling through some of my courses. And that is what led me to my master's at Queen's University in Kingston also. I did my master's and my PhD there. Yeah, Sarah. And that's when I started focusing on human muscle physiology. And I just fell in love with it. Exercise physiology, muscle physiology. It really excited me. The signaling pathways really excited me, trying to understand how we can respond to stress, and that stress being exercise is something that I'm still very passionate about. And I guess in general, I've just been very interested in, as a whole, how do we control our aerobic capacity? And that's what led me to my postdoc. It's a totally different area, working with mice and rats, trying to understand what is happening physiologically to them in conditions of hypoxia or heart failure or anemia. But still, you have the same underlying pathways. And obviously, I mean, I think this stuff is so interesting in my little specific niche, but really that's what started to guide my decisions. What was I passionate about? What did I have joy doing? Because ultimately, that's what you're going to be successful at if you follow what your passion is. And that's what's brought me to where I am now as an assistant professor, just kind of following what I've been passionate about. Yeah.
What an incredibly lovely theme to see weaving through everyone's remarks about how your passion is really driving your career forward. I know that we're going to kind of talk a little bit more about that in our question period. So before we get there, I want to introduce our last speaker, certainly not least, just last, Shreya, who's a translational research associate / research coordinator at the New Brunswick Heart Center at the St. John Regional Hospital. Shreya is a certified clinical research professional and a PMI certified associate in project management. She integrates her versatile skills of academics, management, and clinical research to coordinate clinical trials on cardiac surgery. And her current research encompasses the fields of cardiac surgery, frailty, novel technology interventions to help patients have a better home transition after cardiac surgery, and cardiogenic shock. Shreya, welcome.
Thank you for the good introduction. Thank you for the opportunity to be here among everybody. My career is kind of similar to everybody. I started off with confusion, which happens to a lot of people. So what I felt is I grew up in a family where I've seen a lot of women pursue careers, but mostly they were school teachers with English. So I had this thing, in my family, my mom would push me that you have to learn English, like the good way. And I think she kind of had that vision for me that she would transition into English. But my dad had different plans. So he would be the guy who would give me, like build this out of this toy, like a Meccano or a Lego. Try things out. And I would try everything and I really loved it. So I ended up being that notorious kid who would open toys to see how it worked, but could never fix them. That was my dad's job always. So, I grew up in that environment. My dad would scold me for breaking things, but then he'd not really say much. So there was this balance. I could break, he would fix. So then I learned, how to work with him. I learned to use tools. It's a little bit different in Indian families because women are not looked at that way. But my dad gave me the freedom to be the person I wanted to be. So then I was drawn towards science. So I started doing that for my grade 11, 12. I finished my board exams with the same confusion. What do I do? The same thing. Try everything. Give every competitive exam you can give. Whichever works, then you choose. So I was faced with this choice because I had very good grades in engineering, like for a competitive exam. So everybody had this thing that, she'd get into engineering. She has good grades. So I remember this was, I think, the turning point of my life because I went in for the admission and you have to give like a check as a deposit of the fees. And then I was thinking, do I really want to be an engineer? I mean, I'm not sure. Okay. And I could hear my name being called. My dad is like, go to the stage. They are calling you. I'm like, I don't think I want to be an engineer. Okay. I walked out and my dad he was shocked. He could not believe that. I came home. My mom thought, I have already taken an admission. I'm like, nope, I'm not doing engineering. I'm just going to grad school, like for an ordinary like BSc. My mom had a shock. Okay, she could not believe that. So then again, the choice, what do I want to study? Okay, let's study whatever. So I did that and I did my master's, which happens. And in master's, everybody says you should do PhD. That's the only thing that you can do if you have like a master's. I said, okay, fine, let's try it out. So I started my PhD with a good government scholarship. Like it's very rare to get that, but I don't know how I got it. I think it's just pure luck or a mistake anyway, but I got the scholarship. I started working and I hated it. Like being stuck in the lab doing experiments, that is just not me because I like to go everywhere. And, I was having a hard time. But then, I learned a lot of things, and my PhD degree was a little different because usually, if you work with, for example, molecular biology, you just work with that. But for me, I did a lot of clinical research too. It's a little rare to do that because I worked at a research wing in a hospital. So I had to interact with a lot of patients, look at records. That changed my outlook. Like it was a shock for me initially because I grew up in a family where you go to private, clinics, private hospitals, everything is different. If you can afford it, you don't go to government hospitals because most of them are crap. And I worked at a government hospital. I could just see, poverty, pain, the patient suffering, lack of empathy. So the first year of my PhD was an eye opener in my life. I've never experienced something like that, and I didn't know how to react to it. So I was just withdrawing from it, like as a defense mechanism. But then I realized, I should try to do my part because running away will never get me anywhere. So that's when I started, really interacting with patients, hearing their stories. They have so much to say, I feel. And that's what kept me, thinking that, I have to do my PhD and I want to stay in clinical research because that gives me a good outlook towards life and motivates me to do things, even if it's small. One drop in the ocean might, make like a big ocean someday. So I started doing that. I finished my PhD. Although I hated doing some things, I still felt motivation enough to finish my degree. Then I joined a postdoc where I was again stuck in a lab and I realized that's it. This lab work will never happen anymore. So then I transitioned full time into clinical research as a research coordinator. So I enjoy doing that, talking to, patients, talking to nurses, to physicians. So I feel I'm the kind of person who can have different levels of interactions with people. And I enjoy that. That gives me motivation to do more things. So that's how I started my career here in Canada, like as a clinical research coordinator. That's kind of my path too. Like, you learn along the way what you like, what you don't like. And then at some point of time, it's like, there's no turning back. This is what I really want to be. And I feel the stories patients have to say, that's my biggest motivation to continue my work and, try to learn from them and try to improve myself too. So it's like a win-win situation for everybody, I feel. So you learn along the way, you teach along the way. I try to mentor people to follow the same trajectory, because if you do PhD doesn't mean you always have to get into academics. You can always choose other fields too. There are many other options. And for women, I should say, I feel as a woman we are much more empathetic towards people, and a lot of people come to women to share their stories, their sadness, their pain. Men are good, but there's something about women, I feel like, as caregivers, they're always much more open to receiving different information and feelings from people. So I feel women in STEM, they make a lot of difference. And there's always discrimination, as a woman. Oh, once you get married, you cannot have a career. If you have kids, you'll go on leave. Those things happen all the time. And that's part of life, but that balance is important, I feel. So yeah, so here's the reason I'm here. And I would encourage everybody else to try and see what they love. And at some point of time, you understand, this is your calling, and you try to stick to that. So that's about it.
Thank you, Shreya. Really, really wonderful to kind of see all these different career paths and how you sort of started from the same place of uncertainty and ended in a place where you feel empowered by the decisions that you make in the career that you have. I noted in what you were talking about, maybe some challenges that women might face, and I'm wondering, as my sort of first question to the panel, and I'll also open the chat and Q&A for questions from the audience as well. But my first question is, have you faced any challenges as women studying and working in fields that have been traditionally dominated by males? And if you did, how did you overcome those challenges? Brittany, you want to go first?
Yeah, sure. I think something that really stood out to me when especially early on in my training, is like I'm thinking specifically back to my master's. I noticed that there weren't any female faculty members that were in my field specifically, and even outside of departments. And that included labs that we would collaborate on campus, but also at other universities. They always seemed to be labs that were led by men. And I think the way that I think I would have appreciated having that role model specific to my field, because there were women at the time, but they were like in the States, or they weren't accessible to me specifically in terms of where I was working. And I was just like a brand new little master's student. But I think to overcome that, as I went through grad school, I started to look outside my field for those mentors. And specifically, I can remember the first year of my PhD taking a statistics course with Dr. Latimer Chung and her postdoc at the time, Dr. Shane Sweet, who's now at McGill. They inspired me with statistics, and they're both health promotion researchers. And I've always really appreciated like the new love and passion for statistics that they gave me, but also in terms of Dr. Latimer Chung, I really looked to her in terms of how she conducted herself as a professor, and how her lab was run, and just getting different perspectives from different female researchers, even if they weren't necessarily from my area, and how do they approach science? How do they ask questions? And also looking to senior female grad students in my department. When you go through a tough time, it's nice to be able to talk to those individuals, or even when you're trying to make decisions about your own career path. Someone who's 2 or 3 years ahead of you and has already gone through that can be a really important mentor that can help guide you through some of those processes. And I found that very helpful. And it's something that I've kept throughout any level of training that I'm at. Having someone who's a few years ahead of you in the process can be a huge bonus for many reasons.
Don't think any of us could say enough about the value of mentors and good mentors in our lives. Sowmya, do you want to speak to the challenges maybe?
Sure. Yeah. So I think exactly what Brittany was saying. I think sometimes, you don't see other people like you, and that can be a challenge. But I do want to kind of, start by saying that I've been rather lucky. I've, not like my master's, my PhD, or even my career, there was no traumatic experiences or any major scarring experiences, because we know they exist, right? So I was very lucky that I more or less sort of, floated through all of this in a very protective bubble that was created by my supervisors, my parents, my friends, and so on and so forth. So although there wasn't really any major, luckily, any problems, I think there are small things that one sees every now and then, or I don't know how small, but you definitely see things, I think, as you go through your career. And some of the common ones that I've kind of experienced are things like, you're in a meeting, a committee meeting, and you're the one woman in that committee meeting, and then so no one is there to, really pay attention to what you're saying, or, you'll say something and they'll ignore you, and then another colleague will repeat it and they'll be like, oh, that's excellent, that's amazing, and you're like, I just said that. So there are those kinds of interactions that happen, and it makes you wonder that, oh, maybe it played out a certain way because of factors like gender, your age, or race, and so on and so forth. The other sort of common thing that I've seen happening is, go to a conference and sometimes a male professor will start talking to you with the assumption that you must definitely, certainly be a student. How dare you have a job, right? You're like, so you see these kinds of things. And I think more recently, something I saw is in a grant application where a reviewer was very, I don't know, strange enough to, pick on the one woman who was on the application while happily praising the other two male co-applicants. So these kinds of things happen. And the way in the past, I think I've sort of, I would have ignored it. And, I kind of give people the benefit of the doubt, saying, we make mistakes and people are not doing it on purpose, and, they're not really trying to make you feel bad, and sort of just ignore it. But over time, I've learned that irrespective of whether people are trying to do it consciously or unconsciously, if you don't say it, it will not change. So I think I've learned to, if I'm not happy with how I'm being treated, I will say it. I'll do it in a respectful way, or at least I think I'm doing it in a respectful way. But I will say it. So, when someone says, oh, hey, whose student are you? I no longer smile. I'll say, actually, no, I run a lab, I am a prof, or whatever, right? So I will clarify what I need to say. And the other thing that I think I've been doing, or I tried to do, and it's really hard because I think it's easy to kind of easy to react. When something happens to you, it's kind of easy to react and say, hey, I'm not being treated well. But I think the tougher one that I am trying, and it takes a lot of effort, is to be sort of introspective and sort of, catch myself, because it's surprisingly when other people do something to you, you're like, oh, that seems wrong. But when you're doing sort of like things to yourself and you sort of undermine your own self, you almost let that go, because you're not really reflecting on them. You limit yourself and be like, oh, maybe, I can't do this, or I'm not at Stanford, so maybe, I don't know, I'm not the biggest person in the room, or whatever. Like, nothing against Stanford, but like, I think sometimes we undermine ourselves, or very often we do these kinds of things because of, I don't know, the social norms that you've grown up with and all of that kind of stuff. So over time, I think I've like tried to catch myself when I can and try to correct myself, and open to correct myself, because sometimes, you make mistakes, and if I'm willing to tell other people that they need to fix what they are doing, I should be open to do the same. So if someone turns around and tells me that, hey, that's not how you should be, I don't know, saying this, or you just misgendered me or something, then I'm happy to apologize and learn and correct myself and try to not repeat it. So yeah, that's my 2 cents.
Thanks for that, Sowmya. Sarah, do you want to add to this question?
I just allowed here to some amazing thoughts there about how we play small sometimes as women, as if, a male gender, or like the traditional roles in our jobs are the status quo, or like they're the goalpost of where we should be measuring up. And I would argue that the way women do business differently, if we want to be binary like that, but like just like women as in these roles, if we want to do business differently, that doesn't mean that it's wrong, or that we should be trying to push our role into what has traditionally been a male dominated field. And so like examples that I've encountered are things like when I was pregnant for my first child, a male physician said something to the effect of, "Oh, I suppose you're going to be one of those women now who take a maternity leave, don't you know, Sarah, that like women used to squat in a field and then get on with things." And like and I mean, this would have been, well, my oldest is 9 years old, so this isn't, a million years ago. And you sort of think that like that's what you're sort of up against, as if you need to apologize for taking a path that like, meant that I stayed home with my child and bonded and attached with them, and then came back, I would argue, an even better pediatrician with some life experience, and bring something to the medical table that, men are parents too, but that just is sort of this different feeling and weave throughout our work. And that's what I think that we bring to the table as women, or as just all genders on a spectrum, is just that diversity and inclusion, whether it be our gender or our race or our experience. I see the question in the chat about what I would tell my younger self. And it would be that we don't have anything to prove, that we are enough, that we are worthy to be in these fields, that we are very capable, and that we do it because we love it, we're interested in it, we're good at it, and we're awesome, and not because we're trying to be something that we were told we can't be, because we can easily be these things, and like this panel is a proof of what's possible. And so what I would tell myself, my younger self, is that, you can be an example of what's possible because you can.
That's great, Sarah. I want to actually open the floor to everyone to answer that question. What advice would you give your younger self, or what advice would you give in general young women who are pursuing careers in STEM? What have you reflected on in your career so far? Shreya, do you want to start?
Yes, go for it.
So I have a little bit to add to whatever everybody said. I did my PhD and I had a job too in Kolkata before I came here. So during my PhD, it was a lab full of males, which is quite common. So there are some cultural differences in India, and it's always been like, like you have to go home early. I understand there are security reasons. You cannot really roam around late at night. There are problems in all countries, and especially in developing countries. And if that comment comes to you as in like, oh, you cannot do your work, that's really insulting. Okay. So I would think, like, this is nonsense, but I have to do my work, but I cannot openly fight. It doesn't make any sense to scream at people because these are stupid people. I cannot explain things to them. I don't need to. So I used to make it a point that I would make plans for my work in a way that I'll start early before anybody comes, and before, it's dark or whatever, after 6, I will leave. So I trained myself that there will be obstacles, but I have to overcome them in my way. So even though people started off saying a lot of things, you cannot do this or you cannot do that, PhD needs a lot of work, which a lot of women cannot do. You can always hear those things in the background. I learned to listen to it, but also not really take into me. I just knew that I had to do whatever I had to do. And at the end, results will show. I don't need to prove myself to you. And that's what happened in the end. And there were so like, as in a lot of careers, I had a lot of issues with my supervisor. Lot means lot. But then we kind of realized that we are different people. He's a male with ideas which are like 50 years old and expectations which are 50 years old. And that's not how things go now. And at some point of time, he realized that, let this girl be. She will do things her way and get it done. And now unconsciously people talk about me, but in good terms, like, she made it, she did that's great. So that's what I feel too. Like, these challenges will always be there. Doesn't matter which country it is, like, it's always there. There's always some comparison going on. And especially if they see women who are a little different from the rest, they will try to understand, like, what is wrong with her, why is she doing things which nobody else does. That's always there. But we should never give these things a thought. That's like a challenge you have to take on yourself and show that you can do much better than most people. So my younger self, I would say I used to be a little bit reactive to a lot of things, but over years I tried to take control, especially of my temper. It was bad at one point of time. So now I'm much more calm. Now I think things through. I don't show my anger, but I will put my point across through my work and my behavior. So things I learned along the way. One of the, you need to train your mind to handle different situations. There will be some situation or the other, and you have to motivate people, like not only your colleagues but also like your friends from different fields. You need to talk to them, because as women, every woman goes through something or the other. Like, it doesn't depend on which field you work. If you talk to different women across all careers, you will understand some common themes show up for everybody's life, and you learn from them, and you also share your experiences. So it's like a good sharing of knowledge. It prepares you for what might come, and it prepares them too for that. So that's what I feel like. As women, we should share everything, like especially problems that we face along the way. It's like a growth for everybody.
And helps others feel a bit more validated when they experience those same challenges, to know that they're not alone, and feel a bit more supported. Sowmya, did you want to jump in there? What advice would you give your younger self?
Yeah, I think I would tell myself that I shouldn't worry that things are going to be written in stone. I think that's sort of, I don't know. I don't think anyone told me that, but at least that was my mentality. I was like, once I take an engineering degree or a computer science degree, that's it. The only thing I can ever be is a programmer or whatever, right? And I think over time I realized that's far from true. You can change your mind, and sometimes you take the same tools and you apply it in completely different ways, and usually it's not as rigid as one imagines in their own head. So I think that's something I would tell myself, and I would tell everyone who's getting into STEM careers, saying give it a try. Really, there is not much to lose. Like, I don't think it's a waste of time or waste of energy. If anything, you'll come out of it with good tools to apply later on in other kinds of jobs or things that you do. It gives you a certain kind of a systematic way of thinking through things, which is generally helpful life skill. So yeah, I think I encourage people to try and not, be afraid or listen to someone who says, oh, but girls can't build robots. No, whatever. You do what you want.
Thanks, Sowmya. Brittany, do you want to share your advice for your younger self?
Yeah, I think objectively women tend to undervalue themselves, especially younger women. And I think I would have told my younger self that, like, you're good at this, and don't be afraid to take advantage of opportunities or to ask questions. like, I'm sure other people have had a similar situation. If you're at a conference and you're thinking of that question, you're like, oh, I'm not going to ask because I don't know, maybe I missed something in the presentation. And then someone else asks that question. And that's just one very specific example, but I think just in general, like, don't be afraid to ask for opportunities because you are qualified just as much as someone else to take advantage of them. Yeah.
That's great. I'm going to ask one last question before we close up today, and I'll let everybody get the chance to speak to it. I know we've touched on it a little bit, but why do you believe it's important to encourage and support more women to pursue careers in STEM? What's your call to action that you want to leave us all with today? Shreya, do you want to start this time?
What I find about science is, you need to ask questions, a lot of questions. And sometimes you find a problem, but a problem can have so many solutions. If you are in STEM, that's what you realize. One problem can be tackled in so many ways. So if you use that in your life too, you'll find, there's a problem in life, you think 5 different options, and then you realize, it's not that bad. It's just a problem. So I feel that this thinking, talking, discussing with myself and with people, the way we do in science, we share like a problem, we have a problem, we talk about it, we look at it in different angles, we try to find different solutions to it. That kind of makes life a lot simple too. So I feel like, science actually teaches you that, to have a clear mind, just, remove all the bias, remove all the, emotions, everything, just focus on the problem in hand. And you can apply that to life too. So I feel women in science actually look at life in a much more clearer perspective. And that helps things to go much more smoothly. So I feel, at least even if you don't want to stay in STEM, you want to go to any other field, that's great. But a little bit of training in STEM will actually help you to shine even in some other field, because you already have that nice analytical things going on in your head. So that's my encouragement to everybody. At least for a few years, you should stay in STEM. And then it's your choice what you want to do.
Thanks, Shreya. Brittany, what are your thoughts? What's your call to action?
I think it's incredibly important, not just from a gender perspective, but also from other minority group perspectives, to increase the diversity in STEM. It gives us different perspectives in preventing biases in our science and technology, but also increasing our creativity in how we approach questions, and also the diversity in the questions that can be asked. I think Tori highlighted a really good point earlier in her talk, where a lot of issues that affect women have kind of been ignored for a really long time, or science has specifically asked questions in the context of what's happening in a man or in a male context. And I think that we're starting to focus on women, but I think we still have a long way to go. And I think getting more women involved in STEM and asking those kind of questions is really important for that.
Really well said, Brittany. Sowmya.
Sorry, couldn't find my mouse. Yeah, I think really what everyone already said, I think I just want to reiterate, like, come join STEM. We need you. So please come. And I think other than that, sort of talking about the diversity aspect of, like, we need more perspectives. And I think that's really, really important. If more people show up, that's when change happens. So, like, when more women started being part of universities, that's when childcare supported universities started and things like that, right? So if we have more people, that's when something will happen. Usually it's very difficult to be the lone voice. And so we also need strength in numbers to make change happen. And yeah, so feel free to always, reach out, ask people for advice or chat. And I think I find that most people are very happy to discuss and usually are very generous with their time to help when they can. So don't be afraid to ask and reach out, and yeah, give us a try. We're here. We'll help, and so will everyone else who's here already.
Thanks, Sowmya. Sarah, I'll give you the last word on this.
Oh, geez. No pressure. I think if there was ever a time that like women could bring some extra special skills to the table, it's in these fields where, you know, we really know how to work smarter and at times, and so like that efficiency. And so I think it's nice to think that, you know, I think all people should really reevaluate how we approach our day-to-day lives and self-care and our own path to wellness and how we kind of take every breath each day. And so I just really encourage all of us to sort of say, you know, the days of 7 p.m. meetings when you have a young family at home, or, you know, thinking that working until 2 in the morning is how we become more productive, or things like that. I think it's on us to really shift that frame and know that, you know, we can work smarter, not necessarily harder, and that we can really be an example of that. And so I just like to think that women in STEM sort of challenge the status quo and how we can not have it all, because that might be not fair, but just be able to create the times when we work really hard, and then the times when we say, you know what, this is when I go and rest and recharge and be with my family and things. And we can be an example of how we can still have enormous success and productivity that way, as opposed to always trying to lean in and be something that we're resisting as a sort of natural intuition. And so I love to see that, because I love to see people say, no, I don't do meetings at supper time. That's when I'm doing homework with my kids, you know, because then that means that the rest of the world has to fit into what's happening. Because then we become the people that if we're not at the meeting doesn't happen.
That's a great way to close. And I just want to say thank you to everyone who presented today. You've really left me feeling inspired. I know I'm going to go into this weekend feeling capable of pretty much anything. So I hope that our audience feels the same way. And I want to thank you all for your time and for the insights that you shared with us.
Thanks for having us.
For having us.
Yeah, thanks for organizing as well.
All right, well, have a good weekend, everyone. And take time to yourself and don't have any weekend meetings. Thank you all.
Thank you. Bye.